Hi, everyone. Welcome. I'm Marcos Senasibia, part of the product management team for Autonomous Database. And today we're going to see how to make your application smarter with the use of Oracle Machine Learning and AutoML. So the key takeaways for today is going to be, you're going to see how you can making machine learning and infusing that into your applications, right? Makes that much better, right? For any of your analysis of customers and processes, right? Building also machine learning models using AutoML UI is going to allow you to use it through different APIs, right, and make that application work better. And also increasing the reliability, right, and security of machine learning models. And that comes because of the models that are running inside the database, right? It basically lowered the cost, right, and the usage of third-party packages or engines, right, that you need to move data to. Machine learning use cases are part of every industry, right? You see, all the industries have customers and or products and or equipment and or employees, right? And there are many, many different types of use cases you can see. So if you have customers, you're worried about, customer segmentation, loyalty, customer attrition or churn. And then if you have products, you're looking for the next best offer, right? Cross-selling, things like that. Looking at equipment, you're trying to identify predictive maintenance and things along those lines. And employees, you're also looking at all their best attributes, trying to find similar good employees, right? But what these use cases have is all of them have a different classes of techniques, right? So when you're doing, customer lifetime value or loan analysis or probability of default, you're using one or even more of these classes, right, of algorithms. So you're using classification or using regression or anomaly detection, right, and things like that. And we're going to look at today at a usage of customer churn, right? So that's part of the classification family of algorithms, right? But we're going to see that technique there. And every technique has actually their algorithms themselves, right? So this is a very large list of algorithms. This white list is actually available inside the Oracle database and every Oracle database, and it's part of the Oracle machine learning, right? So we have algorithms for classification and regression, and all of these were created basically looking at what our customers were using, most frequently. As part of the AI and ML, ecosystem, right, across Oracle, the machine learning in database is part of the machine learning for data platforms right there in the middle, right? And that's what we're going to be focusing today. We're also part of the Oracle Converged database, right? So when you think about the database, we are actually in there. So we're part of that process. If you have an Oracle database, we are in there, right? We're part of that process, no matter where, right? So you can see that on the left-hand side here, I have the components listed. This is basically, the different APIs of SQL. API is available everywhere. And we have Python and R that are available in the autonomous database side and also on database on premises, base database service, and Exadata, and things like that. There are three components that are exclusive to Autonomous, which are the Oracle Machine Learning Notebooks and AutoML UI, and also the Oracle Machine Learning Services, right? Our REST endpoint server there. But then Oracle Data Miner is available again against all of these platforms as well, right? So we're very flexible here. The idea for us and the reason why we created the Oracle Machine Learning in the first place, right, was that, there's a gravity, right, on your data, on the volumes of data, large volumes of data, right? Why would you take, terabytes of data out of the database to crunch numbers on, a little platform where you have open source algorithms, right? When you can actually do that directly where the data reside. So saving and eliminating all of that data movement and simplifying the solution architecture is what we were going for. So that's where we run those basic, 30 different algorithms there. At the end of the day, that actually saves a lot of time, right? And basically, it's the data access time and the export the results time. All of those things are eliminated, but also crunching the time for the machine learning modeling, right? The data preparation and exploration and things like that, because those things inside the database and where the database is, right? When your data is running faster, right? So it gives you better, time to production, right, on your project. So we're going to be using the Autonomous Database today for demonstrating to you guys this process. Basically, the Autonomous Database helps you with running the Oracle database, but for the cloud and without requiring you to do any patching, any backup, any worrying about any of those activities. We are actually managing the infrastructure. We're managing the automating all the database, process and management. We're managing all the data center operations. So we have all of that automated for you, right? So you have more time to develop, more time to work with analytics, right? That's the idea for us, right? Is having you to do that. So I'm going to be using now a use case, and this use case is going to be the Oracle movie stream, right? So this is like your Netflix, competitor here, where I have a lot of customers, right? So I have a lot of customers that I need to take care of, and I'm worried about, and I need to actually acquire more customers. But keeping the customers that I have is probably, the cheapest, right? Way of continuous revenue, right? So I'll be evaluating these customers, and I'll try to identify which customers are the most important ones in terms of customers that I can keep, right? So to understand whether I can keep a customer, right, I need to understand why they leave. And the reasons why they're leaving is what we call the churn, right? So I'm going to try to identify the probability of a customer leaving, so probability to churn using machine learning. And then in the way that I can potentially offer something like a pizza promotion to that customer, right? To try to make him come back, right? Or make him stay, right? With our service. So for that, I'm going to assume that I have a data lake, right? In our Oracle Cloud infrastructure. I got lots of different sources, right? I can enterprise applications, movie stream events, right? Third-party data. I also have an object storage where I have landing zone, gold zone, and sandbox, right? And the idea here is that I'm going to be using the autonomous database for working with that data, right? Once that data is loaded and cleaned up and prepared for me. I'm going to be showing you the model portion and the deployment portion of the machine learning components there. There are many other tools that are available in autonomous database for self-service, like loading and transformations and graph and things like that. I'm going to be focusing specifically on the machine learning side. So the problem with the traditional machine learning is that usually what happens, for data scientists like myself is you start the process by selecting one of those algorithms, right, that we talked about before. Now, I pick up one of those algorithms at a time. I then go to evaluate that algorithm against data, come up with one algorithm or one model, right? But then I have to create and optimize that model. So I start playing with all the different, components and the different parameters, right, that each model has until I get, one model, or I get a bunch of versions, right, that are the best versions for that model. Those are the things that I'm doing. But then I have to rinse and repeat that process, right? So now I have to restart the entire process again using the next algorithm, right? So what AutoML or automated machine learning does is actually eliminates that repetitive task, right? All of those process of building and evaluating every different algorithm, right? It's going to use something called the auto algorithm selection. So it's going to look into all of these algorithms, and then it's going to go and say, okay, out of all of these algorithms, which ones are the ones that actually best work for your problem, for your data? Next step is going to go and do an adaptive sampling. It's going to identify, what is the right size of a sample, right? Make it proportional and do the analysis that it needs to best perform, right, for each model. And then it's going to do an auto feature selection. So things like, color of the eyes, the name of the customer, or the shoe size shouldn't matter, right? To evaluate the process of whether the customer is going to stay, right, or not. So it will eliminate all of those things automatically. And then you can go into auto model tuning. It's going to do and increase the accuracy of each of the models by tweaking a little bit all of the parameters that it has, right? So that process basically is going to enable even someone that is an experienced data scientist to actually save time as well. So I'm going to be showing you and simulating that I am that data scientist right there in the middle here. And I'm going to be working on deploying this model in several different ways. you're going to see the different capabilities and different UIs that we have available for that. And then finally, I'll talk about how that developer, right, that person, that app developer person can actually use that to really at that point create, right, the application there, right? So I'm going to start then on my demo. Basically, here is the Oracle Cloud Infrastructure. So I'm inside the Autonomous Database console here, right? So I have my Autonomous Database console, and in the console, I have something called Database Actions, where you can create users and things like that. But I'm going to click on the View All Database Actions. Okay. So this is the Database Actions then, and you can see that I have a lot of different tools here. As I mentioned, tools for data loading and transformations and things like that, right? And managing things. But on top here, I have the development tool, right? And specifically on this one, I have the Oracle Machine Learning, okay? So when you click on that, you get here. This is the Oracle Machine Learning UI. And I'm the user movie stream. And what I'm going to do here is I'm going to click on AutoML, right? And I'm going to look at the AutoML experiment. There is an experiment there already, but I'm going to create a brand new one to show you guys step by step, right? So we want to detect customers about to leave, right? I can put any comments. And the first thing I need to do is I need to get a data source, right? If you look at the table, and then on the right, I have here the table, I have the schema. So all the schemas that my Oracle database user has access to, and all the tables in there, right? So I have access to this table. I'm just going to click on it. And now what the system is doing is actually showing me down here. You can see all of the different features, right, that I have there. So I have things like age, average number of transactions, right? I have transactions 3 months ago, 4 months ago, 5 months ago. Sales, same thing. Discounts, average number of transactions in the last quarter. CD, credit balance, customer ID, right? All of these different discounts, education, email, and then things like gender. And then I start genre, right? Movie genres. How many movies of genre action the customer watches? How many movies of the adventure, animation, biography, comedy, things like that, right? And then at the end here, I have even more things like household size, income level. And the most important here in this case is churner. That specific feature is telling me whether a customer left last month, right? Or he stayed, which means he had 0 watches on the service last month, okay? Churner definition is something that all companies, all businesses do differently. You could have thought about something like, well, the customer reduced their watch levels by 90% or something, right? Which it is an indication that they're probably watching movies somewhere else, right? So this is just an ample definition that all companies do differently. In this case, I have a 0, 1, a binary target here that says the customer left last month. He didn't watch any movies with me, okay? And then finally, a few other columns like marital status, the location, latitude and longitude, and years as customer and things like that. Very well. So I defined then the prediction, right? What I want to try to predict is whether the customer is going to stay or going to leave, right? So it's the is churner. And then the case ID here, I'm going to go to customer ID, right? Now, because I selected this churner and the churner is a binary 0, 1, it's going to automatically detect the prediction type of classification. I can see that it could have done regression if I'm trying to predict something else like customer credit limit, right? Or other things like that. All right. So back to the features here then. I can, manually remove things like I don't even want the system to try to use. So maybe first name and last name, I know they have nothing to do with whether a customer is going to stay. And if they did, it probably would have been wrong, right? So you don't want to use that. Then in additional settings here, I will reduce the number of maximum top models to 3. So let me check the top 3 models here. I have the maximum duration. It's okay, the default. Database service level. So Autonomous Database have low, medium, and high service levels. Medium allows me to do parallelism. So I'm just going to turn it to medium. And then the model metrics. So the data scientist is going to choose, maybe a different model metric like accuracy, like area under the ROC curve, F1, or precision or recall, depending on what they're optimizing for. Okay. And the list of algorithms, right? So this is just something you can uncheck if you want. Something like, companies like in the financial services that actually work with credit scoring, they are not allowed in the USA to use a neural network, right? Algorithms, right, to define their credit score. So they need to use something else, GLM, right, or decision trees. So you could potentially uncheck neural network here and just not make use of that, but let it run through the other ones and see which ones are the best, right? All right, so having said that, I'm going to click on here. I'm going to click faster result. That's basically is going to run faster. If I selected better accuracy, it's just going to do a little more tuning, right? A little more fine tuning, so it's taking a little more time. So I'm going to just let it run. So it's starting my experiment right now. So after a basic initialization phase here, is going to then start working in the in the second step here. That's going to be the leaderboard where you're going to see the selection of the best algorithm, right? So the first step is going to be now algorithm selection, right? That's going to be happening here. So every step that it takes, so is going to do algorithm selection. After the algorithms are selected, right? Remember that I requested 3. I'm going to go and it's going to go automatically and do adaptive sampling. It's going to go through feature selection, and then it's going to do a final model tuning and a prediction impact analysis of every feature for all the models. Okay. So I can see the first, initial balanced accuracy, right, of that table of the database. And now, once it runs through the algorithm selection like it just did, here in the leaderboard, you can see it selected the decision tree, a random forest, and a support vector machine that is a linear kernel, right? These 3 algorithms are the first ones, or the best ones that it identified initially. Now it's going to go through an optimization here for them. So I'm going to just leave this experiment running. And I'm going to open up another one that just ran. So you can see it's running here on top, right? So this other one that I just ran actually completed in around 3 minutes. And you can see all the steps that it took, right? So it ended up that the random forest is the best one for balanced accuracy, right? If you click on that model in the link, this is what, this is showing basically all of the different features and their weights, right? Their importance for that model in particular. So basically saying, age and gender, right? Gender, education, how many thriller movies the customer watches, average number of transactions in the last quarter, years of residence, credit balance, general family, and general war. These are the features that actually make this model important. And the confusion matrix here shows me the errors, right? So I predicted that the customers were not going to churn, and they did not. The model was correct 64% of the time here, or 64% of the population falls into these guys. And then 28% of the population falls here, where I predicted they were going to churn, they did. Where the model missed was 6% of the people, I thought they were going to churn and they didn't. It's not terrible, because if I'm offering a pizza, it's fine. I'm going to be sending pizza to people that did not necessarily were going to churn. But again, it's okay, right? Now, this 1% of people here, I might be more important, more critical to look at right later, because those guys I could not predict. They actually churned, but I did not predict they were going to. So again, it's not a large volume compared to this, right? But it's still okay. So these are things that I can do later. All right, now that model is built, I can do a rename. So I give the model an interesting name. I already did that for churn pred. So I can reuse that model. It's already there in the database with these names here, but I can reuse that model for other things like scoring immediately, right? I can then create a notebook, or let me first create select metrics. So you can select different metrics here and compare models, right? So that just shows me different metrics that I was not optimizing for, but I can see how they look like, right, after the models are done. And then I can create a notebook that basically takes this model here, and it builds an entire notebook that actually is written in Python using all of the steps that AutoML actually did. All of this optimizations, every single thing that the AutoML was doing is going to be translated into Python, and then you're going to be able to see that notebook. And we're going to go there soon. And then the other thing that I can do here is I can deploy the model. So I can deploy this model to a new URI. So if I give it a URI name, a version, and a namespace, this goes to what we call the Oracle Machine Learning Services. That's our server for autonomous database users or customers. And with that, you can actually score immediately using REST against that model there. Okay, so we're going to see all of that. So now, first things first, if I come here to the notebooks, then I can see that notebook that was generated for me, right? So this notebook that is generated is going to have some comments about the model originally, right? The experiment, and then it's going to talk about the data. So it's going to actually step by step here is going to import the Oracle Machine Learning package for Python, right? Inside a Python session, is going to create a new what we call proxy object, right? That points to this table with these columns. So it's basically creating a view behind the scenes that is a query based on these columns that were actually the ones identified by AutoML to be the best ones, the ones that were needed by this random forest, right? And then it creates what we call a proxy object. This is not pulling the data back to Python's memory. This is just a pointer to the data that is in the database, okay? That new view that was created. Now, I prepared the data for building the model, and then finally, here I have the exact settings that the AutoML model identified as being the most important settings for that random forest, so that I can reproduce exactly that random forest model that I have, okay? So exactly how many, the impurity metric that I'm using, how many, minimum percent split per node, how many, the tree depth, right? Max depth. So all of these things were the settings that random forest requires that actually were identified by AutoML process, right? And then I'm building the model, so I can build that model, and you can take that model and work with it or rename it, give it a name, run it on a different server, right? And things like that, right? Now, how can I use that? So first things first, I'm going to show you here, I have a scoring, right? So I have a scoring process that I'm going to show you where I can actually use that model for scoring. So first things first, another user, doesn't have to be my own user, another user imports the OML library, does the send, right, requests the proxy object to be the entire table. It's okay. But then I bring in my random forest user that I called churn pred, and I can just run a prediction. Okay. With the output of that prediction, I have probability to churn now. So I have all of the customer ID, the information about the customer. I have now probability that this customer is going to leave, and a prediction, 0, 1, right? So same thing with SQL. I can actually repeat that process with SQL, and you can see that right here, right? So I have prediction and prediction probability. These are things that are exclusive to the Oracle SQL, right? So I have prediction and prediction probability on churn. This is dynamic SQL, so it selects star, and I'm dynamically scoring every customer available here on that table, and I'm getting their probabilities to churn right here, okay? Now, the deployment that I just did is actually to the REST endpoint, right, to the Oracle Machine Learning Services. So I have now that model, so I'm going to just get a token passing my Oracle database username, right, and password. And now I can predict. Remember that I called it churn pred, right? So this churn pred REST endpoint now is alive. I am passing, and now as the application developer, right, I'm just passing this input records and passing some data about that customer, right? So I click send, that data goes and comes back. I can see that the result came back in 47 milliseconds. So that's very fast between, my home here in Miami and the server that is in the Northeast. And I see the probabilities here, right? So this is basically the probability that this customer in particular, this one that we sent, is going to churn, 84%. But more than that, because the top end details here is 5, what I'm saying is I want to get the top 5 prediction details or the top 5 reasons why this model thinks that this guy is going to churn. And I can see the reasons here and their weight. So age, the number of movies, of war movies the guy watches, the number of thriller movies he watches, how many years of residence in the genre family. Okay. And this can also use micro batches. So I can have, in this case, I have 100 customers as an example. No, a micro batch here that I'm running, right? Same thing. I can just run that scoring and I'll get, all of these results, still sub-second, right? And I get 100 customers with all their probabilities to churn here, okay? So you can see that my application can, we can handle all of that 101, right? Because I started counting in 0. You can count and you can run this process very fast, okay? Back to my slides then. What I do then after that process, right? So we saw that we could use Python and R, right? We saw Python, right, being used as the engine, but we can use R as well. And we basically empower all data scientists using their own native language, right, that they want to program in, but they can actually use all of the in-database capabilities, right? In addition to that, for the autonomous database, we have the REST endpoints as well that can be used, right? And then remember that I mentioned that I was going to show you guys AutoML. The UI side was part of the autonomous database. Well, you have AutoML as well available in Python, and this can run anywhere. It doesn't need to be the autonomous database. It can run on premises. It can run on an Exadata. You have this Python AutoML UI, AutoML API that you can run, and then just give the model a name. You can score that with dynamic SQL, like you can see here on the right. You can also use PL SQL, right, to build a model, and that's something we have supported all the way back to Oracle 11G release, right? But basically, this is the in-database model building using PL SQL on the left, and on the right, I can actually reuse that model in Python, and I can, use a decision tree model in Python and run inference with that, right? I also can build a decision tree with Python and score in SQL, or I can even use R and build an in-database decision tree model like I'm doing here on the left, and then again, use SQL. So there's a lot of flexibility for data scientists. Okay? Finally, one of the most flexible portions we have is the embedded execution. You can actually write your own code, your own R or your own Python, code, and run your own third-party package, whatever you are looking for, and we can actually package it up. We actually spawn the R or Python session needed. The database is controlling that. The database injects the data needed on that session, right? Runs that code that you wrote, and then brings back the results. We can bring back the result into the database or to an object storage or to a file service or, any thing that you need there, right? So it is, again, very, very flexible and very powerful. All right, so recently we released an Oracle Machine Learning Services data and model monitoring. So basically what we're trying to avoid here is, data over time changes, right? Your customer behavior changes, the economy changes, and what people are doing changes. There's something trending up and down. So all of these things affect data, right? The data coming in. So you want to avoid that data drift, but also the model monitoring as well. So we're looking at the model. We also added, in addition to these things in OML services, then we added UIs for those, right? So we have this UI available there for you where you have data monitoring. You're looking at any drift, right, over time for that process. And then things like, looking at the features, whether they are changing over time, right? And then we're evaluating them with specific metrics, right? With some statistics, population stability index, things like that, that you can choose and evaluate, right, the specific processes that are happening. And also on the model monitoring side, where you can monitor several algorithms, right, at once. So we're looking at all these different algorithms, and some of them are drifting more than the others, right, depending on their model, on what model it is. So you can actually evaluate them, look at feature impact, look at the predictive impact over time. Okay. So last but not least here, the roadmap for Oracle Machine Learning Components, right? So basically, these are the things that are being launched and announced, and we're going to be working on for the rest of the year, working on different things and including GPU availability for things like LLM inferencing and embeddings and things like that. And then I hope you guys had a good time watching this session. These are the key takeaways. Again, machine learning can infuse your applications with critical intelligence, right, about your customers and processes. Building these machine learnings using AutoML UI is very easy, and you can see you can deploy them to different APIs, right? And then also we talked about the reliability, right, and the security of building these models in database, right? They are objects inside the database, right? These are some of the links that you guys can go for more information. Live Labs, right? You can go into a workspace in Slack to find us there, LinkedIn, and things like that. So with that, thank you very much for watching the session and appreciate it, and have a good day.